welcome to back to this video on Bitcoin. Creating the outputs. A transaction output is created in the form of a script that creates an encumbrance on the value and can only be redeemed by the introduction of a solution to the script. In simpler terms, Alice's transaction output will contain a script that contains something like: the output is payable to whoever can present a signature from the key corresponding to Bob's public address. Because only Bob has the wallet with the keys corresponding to that address, only Bob's wallet can present such a signature to redeem this output. Alice will therefore encumber the output value with a demand for a signature from Bob. This transaction will also include a second output. Because Alice's funds are in the form of a 0.10 BTC output, too much money for the 0.015 BTC cup of coffee, Alice will need 0.085 BTC in change. Alice's change payment is created by Alice's wallet as an output in the very same transaction as the payment to Bob. Essentially, Alice's wallet breaks her funds into two payments, one to Bob and one back to herself. She can then use spend the change output in a subsequent transaction. Finally, for the transaction to be processed by the network in a timely fashion, Alice's wallet application will add a small fee. This is not explicit in the transaction. It is implied by the difference between inputs and outputs. If instead of taking 0.085 in change, Alice creates only 0.0845 as the second output, there will be 0.0005 BTC, half of a millibitcoin left over. This inputs 0.10 BTC is not fully spent with the two outputs because they will all add up to less than 0.10. The resulting difference is the transaction fee that is collected by the miner as a fee for validating and including the transaction in a block to be recorded on the blockchain. The resulting transaction can be seen using a Blockchain Explorer application as seen in figure 2.8. Adding a transaction to the layer. The transaction created by Alice's wallet application is 258 bytes long and contains everything necessary to confirm ownership of the funds and assign new owners. Now the transaction must be transmitted to the Bitcoin network, where it will become part of the blockchain. In the next section we will see how a transaction becomes part of a new block and how the block is mined. Finally, we will see how the new block, once added to the blockchain, is increasingly trusted by the network as more blocks are added. Transmitting the transaction. Because the transaction contains all the information necessary to process, it does not matter how or where it is transmitted to the Bitcoin network. The Bitcoin network is a peer-to-peer network with each Bitcoin client participating by connecting several other Bitcoin clients. The purpose of the Bitcoin network is to propagate transactions and to blocks to all participants. How it propagates: any system such as a server, desktop application or wallet that participates in the Bitcoin network by speaking the Bitcoin protocol is called a Bitcoin node. Alice's wallet application can send the new transaction to any Bitcoin node it is connected to over any type of connection: wired, Wi-Fi, mobile, etc. Her Bitcoin wallet does not have to be connected to Bob's Bitcoin wallet directly, and she does not have to use the internet connection offered by the cafe, though both of these options are possible to any Bitcoin node that receives a valid transaction it has not seen before will immediately forward it to other nodes to which it is connected, a propagation technique known as flooding. Thus, the transaction rapidly propagates out across the out across the peer-to-peer network, reaching the large percentage of the nodes within a few seconds. Bob's view. If Bob's Bitcoin wallet application is directly connected to Alice's wallet application, Bob's wallet application might be the first node to receive the transaction. However, even if Alice's wallet sends the transaction through the other nodes, it'll reach Bob's wallet within a few seconds. Bob's wallet will immediately identify Alice's transaction as an incoming payment because it contains outputs redeemable by Bob's keys. Bob's wallet application can also independently verify that the transaction is well formed, uses previously unspent inputs, and contains sufficient transaction fees to be included in the next block. At this point, Bob can assume with little risk that the transaction will shortly be included in a block and confirmed. Bob's view. Okay. Bitcoin mining. Alice's transaction is now propagated on the Bitcoin network. It does not become part of the blockchain until it is verified and included in a block by a process called mining. The Bitcoin system of trust is based on computation. Transactions are bundled into blocks which require an enormous amount of computation to prove, but only a small amount of computation to verify as proven. The mining process serves two purposes in Bitcoin. Mining nodes validate all transactions by reference to Bitcoin's consensus rules. Therefore, mining provides security for Bitcoin transactions by rejecting invalid or malformed transactions. Mining creates new Bitcoin in each block, almost like a central bank printing new money. The amount of Bitcoin created per block is limited and diminishes with time following a fixed issuance schedule. Mining achieves a fine balance between cost and reward. Mining uses electricity to solve a mathematical problem. A successful miner will collect a reward in the form of new Bitcoin and transaction fees. However, the reward will only be collected if the miner has correctly validated all the transactions to the satisfaction of the rules of consensus. This delicate balance provides security for Bitcoin without a central authority. A good way to describe mining is like a giant competitive game of Sudoku that resets every time someone finds a solution and whose difficulty automatically adjusts so that it can take approximately 10 minutes to find a solution. Imagine a giant Sudoku puzzle, several thousand rows and columns in size. If I show you a completed puzzle, you can verify it quite quickly. However, if the puzzle has a few squares filled in and the rest are empty, it takes a lot of work to solve. The difficulty of Sudoku can be adjusted by changing the size more or fewer rows and columns, but it can still be verified quite easily even if it is very large. The puzzle used in Bitcoin is based on a cryptographic hash and exhibits similar characteristics. It is asymmetrically hard to solve but easy to verify, and its difficulty can be adjusted. Jing, an entrepreneur in Shanghai, Jing runs a mining farm, which is a business that runs thousands of specialized mining computers, competing for the reward every 10 minutes or so. Jing's mining computers compete against thousands of similar systems in a global race to find a solution to a block of transactions. Finding a solution, the so-called proof of work POW, requires quadrillions of hashing operations per second across the entire Bitcoin network. The algorithm for proof of work involves repeatedly hashing the header of the block and a random number with the SHA-256 cryptographic algorithm until a solution matching a predetermined pattern emerges. The first miner to find such a solution wins the round of the competition and publishes the block into the chain. Jing started mining in 2010 using a very fast desktop computer to find a suitable proof of work for new blocks. As more miners started joining the Bitcoin network, the difficulty of the problem increased rapidly. Soon, Jing and other miners upgraded to more specialized hardware, such as high-end dedicated graphic processing unit GPUs, such as those used in gaming desktops and consoles. At the time of this writing, the difficulty is so high that it is profitable only to mine with application-specific integrated circuits ASIC, essentially hundreds of mining algorithms printed in hardware running in parallel on a single silicon chip. Jing's company also participates in the mining pool, which, much like a lottery pool, allows several participants to share their efforts and rewards. Jing's company now runs a warehouse containing thousands of ASIC miners to mine for Bitcoin 24 hours a day. The company pays its electricity costs by selling the Bitcoin it is able to generate from mining, creating some income from the profits. I'm going to leave it here today for this video. If you like listening, please consider like, share and subscribing. Thank you.